Okay, let's dive into this. Welcome to today's explainer. We're about to take a seriously fascinating journey through the 76-year evolution of artificial intelligence. You know, if you've been using the incredibly advanced reasoning models we have today in May 2026, you're probably wondering, how exactly did we get here? Well, today, we're going to demystify that whole timeline. We're going to explore the massive technical hurdles human ingenuity had to overcome, charting the path from those clunky early experiments all the way to the autonomous, deliberative reasoning agents that are literally reshaping how we work right now. So here's our cognitive roadmap for the explainer. First, the age of rigid rules. Then, learning from the data. Next, the 2017 transformer breakthrough. After that, the rise of System 2. And finally, the jump from chatbots to autonomous agents.
All right, Section 1. The age of rigid rules, the era of symbolic AI.
Now, in the very early days, computer scientists fundamentally believed that human intelligence could be perfectly simulated using strict logic. The whole idea was, hey, if we can just hand code enough rules, a machine could think. It all kicked off back in 1950 when Alan Turing proposed the Turing test, basically establishing linguistic performance as a proxy for intelligence. By 1956, the actual term, artificial intelligence, was officially coined at the Dartmouth Conference. Then, jump to 1966, and an MIT chatbot named Eliza completely shocked the world by simulating a psychotherapist using really basic pattern matching. Actually, fun fact about Eliza, even though it was just a simple script, users became deeply emotionally attached to it, which completely caught its creator off guard. But, that initial excitement, it evaporated pretty quickly. The technology hit a massive technical wall, and that triggered the first AI winter in the 1970s. So, what happened? Why did it fail so spectacularly?
Well, the crucial point is, this led to the ultimate bottleneck, the combinatorial explosion. The symbolic AI approach just completely hit a wall. Think about it. You simply cannot write a rigid hand-coded recipe for every possible variation out there in the real world. Imagine trying to write a hard-coded rule for literally every single way a human can sit in a chair. It's impossible. A machine following a strict if X, then Y script is going to instantly break the exact moment it encounters a scenario its programmer didn't explicitly anticipate. So they absolutely needed a totally different approach. Moving on to Section 2, learning from the data, the machine learning paradigm shift. To smash right through that combinatorial explosion wall, researchers in the 1980s and 90s realized they had to completely flip their methodology. Think of symbolic AI as a strict recipe book. It is incredibly brittle. But with machine learning, instead of handing the machine the rules, you give it a massive data set and tell it what outcome you want. You basically let it infer the rules and the patterns all on its own through trial and error. Machine learning totally solved that rigidity bottleneck because it learned from examples, making it infinitely more adaptable to the messy, unpredictable reality of our world. As this data-driven approach evolved, it matured into what we call deep learning. And by the 2010s, three massive catalysts converged all at once. We saw vastly improved algorithmic architectures, the adoption of GPUs, which allowed for super high-speed parallel computing, and, of course, the absolute explosion of massive labeled datasets from the internet, which honestly highlights just how pivotal human internet usage was to training these models. This convergence allowed neural networks to master really complex tasks like image recognition. But as they tried to scale this up to complex language, they hit the next massive bottleneck, processing sequential data efficiently.
Which leads us right into Section 3, the 2017 transformer breakthrough, solving the sequence bottleneck.
Now, this is the moment that fundamentally changed the trajectory of the entire tech industry. The transformer architecture introduced a groundbreaking mechanism called self-attention. See, older models had to read text sequentially, step by step. That was super slow, and it caused the model to literally forget earlier context. It was kind of like reading a book word by word with a tiny flashlight in the dark. Self-attention, on the other hand, just turns on the ceiling light. It lets the AI see the entire page all at once. And this brilliantly illustrates how the transformers smashed the sequence bottleneck by allowing for massive parallelization. This specific architecture is the literal foundation for the large language models, or LLMs, we use today.
But here's the thing. As amazing as those early LLMs like the original GPT models were, they had a fundamental limitation. They functioned as System 1 thinkers, if we borrow the famous analogy from psychologist Daniel Kahneman. They were incredibly fast, highly intuitive, and honestly, they felt like magic. But ultimately, they were just highly advanced autocomplete tools. They were predicting the very next word based on statistical probability, without any true underlying deliberation. Basically, they couldn't pause to think.
Which brings us right to our current landscape. Section 4, the rise of System 2,
the 2026 era of deliberative reasoning.
Eventually, the tech industry hit a reasoning bottleneck with those standard LLMs, and that required a major shift to models that can actually deliberate. The solution? Test time compute. Instead of front-loading all the intelligence into the initial training phase, our 2026 models allocate extra computing power during the inference phase, meaning at the exact moment you ask them a question. This allows a model like OpenAI's O3 or DeepSeek R1 to generate hidden internal chains of thought. It is quite literally deliberating in a closed room before it ever opens the door and speaks back to you. Now, what's really interesting here is how different these two paradigms are. Standard LLMs act a lot like race cars. They're fast, reactive, and intuitive. They just spit out the next likely word without any self-correction. But reasoning models, those are System 2 thinkers. They are slower. They deliberately explore multiple paths, and they explicitly check their own work against the constraints you give them. It's a huge shift. AI has evolved from a reactive responder into a deliberate thinker.
So what is actually happening in those hidden tokens before the model answers you? Well, it's executing a hidden System 2 loop. First up, it explores multiple hypotheses to try and solve your problem. Second, it actively self-corrects emerging errors as it works its way through those different paths. Third, it verifies its logic against the specific constraints you provided in your prompt. And only then, in step 4, does it output the final verified answer.
This massive jump in reasoning has completely broken our old ways of testing AI. I mean, by 2026, older benchmarks like the GPQA Diamond, which, by the way, tests PhD-level science questions, were nearly saturated. Models like GPT-5.5 are scoring above 94% on that. So now, we absolutely have to rely on tests of fluid intelligence, like ARC-AGI-2, and Humanity's Last Exam, or HLE, just to separate these highly advanced reasoning systems. We are quite literally running out of human tests that are hard enough to measure them.
And that brings us to Section 5, Chatbots to Autonomous Agents, the operating layer of civilization.
Okay, we really need to talk about why this matters to you right now. This specific technological jump in reasoning is exactly why AI has stopped acting like a glorified search engine and really started acting like a capable coworker. We are officially in the era of the 2026 agentic workflow. Because these models can now reason and self-correct, we've shifted way away from simple chat interfaces. AI models now act as the actual planners orchestrating multi-agent loops, where one AI plans, another executes, and a third verifies the work. Plus, hybrid architectures combining transformers and Mamba now allow these systems to process millions of words flawlessly without losing their train of thought. They are deeply embedded across the entire software development lifecycle, analyzing whole codebases and deploying solutions totally autonomously.
Let's move to a great perspective on this to see how this builds into our daily professional lives. Consider this insight from Assist software. The next frontier is the shift from tools to agents. Preparing now means upskilling teams to work alongside advanced AI agents, not just AI chatbots. I love this because it perfectly humanizes the impact of what we've been discussing. These technical leaps have created an absolute urgent need for widespread AI literacy in the workforce. You are no longer just prompting a tool, you are essentially managing a digital team.
So I want to leave you with this provocative thought to chew on. Now that AI systems can autonomously plan, reason, and self-correct using test-time compute, what is your uniquely human role in the 2026 workforce? It's no longer just about generating content or writing code. It's really about how you direct, evaluate, and collaborate with these reasoning partners. Thanks so much for joining me on this explainer. I really hope this helps you navigate this incredible frontier of integrated intelligence.